So without further ado, I'll leave it to Andy, and I think Andy will be able to take a couple questions when he's finished. But we'll go from there.
All right.
Thanks.
Well, thank you, everybody. Thank you for having me, and thank you to Paul and Christian for putting everything together. My name's Andy Trice, and I'm a developer evangelist with Adobe. And whenever I give a presentation, I actually like to treat them as conversations. So at any point in time, as I'm talking about data visualization with web standards, if you have a question, feel free to raise your hand, interrupt me. Because what I've found is that through a lot of these presentations and the conversations that we have with people, really great topics of conversation come out of this. So, there might be something that someone on this side of the room has a question about, which spurs a question from this side of the room. Next thing you know, we're all engaged, we're all talking, and great ideas come out of that. So, I'm here to talk tonight about data visualization with web standards. And so, let me go ahead and get started. Data visualization. I don't think anyone would be in this room if they really weren't aware in some fashion of what data visualization is. But let me take a step back. Instead of focusing on the data visualization, let me try and figure out where everybody's coming from. So how many people in the room would consider themselves from a developer background? Okay. How many people are coming from like a design kind of background? Okay. And how many people would think they're coming from, characterize themselves as like a scientific type of background or mathematical? Okay. So it's a nice mix. I would say with a little bit more designer and developer than mathematical. So the content of my presentation is going to be fairly technical. I'm going to talk about kind of the nuts and bolts of how you create interactive visual scenarios, essentially, that allow you to represent data inside of a web browser. I'm going to talk about the underlying technology, the techniques that you go about building these types of interactions, making them rather than static, actually interactive so that people can do fancy things with them. But I'll try not to get so technical that the people who aren't necessarily technically focused don't understand what I'm talking about. So with that said, data visualization to me is a visual representation of data information. It's a way to put together shapes or numbers or whatever it is in a visual fashion to clearly express an idea. So the whole content of this presentation, I'm trying to focus on that idea of putting together shapes or textual elements or something to create a visual piece that explains information to whoever your target audience is. Now, as I have up here on the screen, some of you may be wondering, why is this guy from Adobe talking about HTML? Don't they have Flash? Okay, yeah, a couple people laughed, so you know what I'm talking about. More people laughed, okay, then more people know what I'm talking about. But let's take a step back and look at the history of computation, in modern history, so just what's happened in, let's say, the last 5 years. Retrospective. Flash used to be the only really good way of creating interactive data visualization on the web. Even 5 years ago, the capabilities of HTML weren't there. And just so I'm clear on this, is pretty much everyone familiar with just what HTML is? Okay, I see a lot of hands nodding. That's good. Otherwise, I'd have to take a step back. But Flash, you can create some really, really highly visual interactive scenarios. Like there's a lot of really cool things that you can do with it. And what's interesting is the roadmap of Flash right now is targeting a premium video and a premium gaming experience. So you can create like super, super high-end these interactive experiences. But what we're starting to see is that as mobile devices proliferate, it's not available on all those different platforms. And so, as a company, we've started investing more heavily in HTML and HTML-related tools. So, thinking back still on the Flash side of things, how many people have used this chart? That's all the hands, really? Okay, how many people have tried to rebuild this chart on their own? Okay, I've tried to do it too. It's kind of fun. But this is Google Finance. This was a hugely popular Flash-based data visualization for financial information. Still huge today. Lots of people use it all over the place. Here's an example of data visualization piece. And the examples I'm going to show you, some of them I put together, some of them I did not put together. I obviously, with Adobe, I'm not with Google. I didn't write the Google Finance chart. This is a data visualization that's a Flex application, and Flex is a framework for creating programmatic application experiences on top of Flash platform. It was put together by a team at, I guess they're IBM now, iLog. They have visualization components. This is all based on Flash platform, so we have lots of nice fancy charts and effects and things like that. It's still a great interaction, but as I said, technology trends have shifted. About 6 years ago, there was a device that was introduced to the market that changed a lot of things for a lot of people. So with that, I mentioned times have changed. Not all mobile devices support Flash. And what's interesting is if we start to think about devices as computers instead of just as a phone or a tablet. Okay, let's not even take the phone into consideration right now. If we take about the tablet into consideration. In Q4 2012, I think it was Q4 2012, if you include the iPad in the total computer sales for that quarter, I think it was iPad. There's a staggering statistic where I think it was like 1/4 of all PCs sold in that period were iPads. They're iOS tablets. So this is like a huge player in the game. We have to create experiences that are going to run everywhere. They need to run on tablets. Whether it's iOS, whether it's Android, because another interesting thing is that the two predominant operating systems for mobile devices right now are iOS and there's Android. And even on Android devices, if you're targeting Android 4 and later, which is the latest version of them, there's not a version of a Flash player to run on that. No, you can use Adobe Air, which is a tool for building natively installed mobile applications to do highly interactive visual type of experiences as natively installed apps. But that's not going to run in the browser for you. So if you want it in the browser on these mobile devices, you need to go with an HTML-based approach. During this time, actually the capabilities of HTML have changed. How many people have heard or are familiar with the buzzword of HTML5? Okay, just about everybody. Then, how many people have actually sat down and kind of studied what exactly is HTML5? What's this buzz all about? Like, what does it really do? Okay, so HTML5 is an evolution of the HTML language. So HTML is a declarative markup language that's generally used to structure information on the web. If you think about the structure of a web page in memory in the browser, it makes up your DOM, which is your document object model. And HTML5 adds some really interesting capabilities. So it's not just about static textual content. It's also about adding interactivity. So you have things like the Html5 Canvas, which is a programmatic drawing surface. You have an SVG, which has become a part of the HTML5. It's kind of lumped in under the HTML5 umbrella. But that's for scalable vector graphics, which I'm going to get into these in a little bit more detail in a moment. You also have to think about there's new JavaScript APIs that might reflect with geolocation. There's CSS3 styles. There's all these things under HTML5. But the point that I'm getting to is that HTML5 as a platform itself has evolved in order to be able, and it allows us to be able to create really highly visual, highly interactive, like rich types of experiences that are totally dynamic and totally change on the client side without having to do like round trips to a server. So why else is an Adobe guy here talking about HTML? It's because we love HTML. We have a new line of tools. So the Adobe Edge suite of tools and services are tools that are focused entirely on developing app experiences with HTML. Now, I'm not going to go in depth on all these different ones, but we have everything from timeline-based animation to responsive design tools to code editors, synchronized. Edge Inspect is cool when it's a synchronized browsing experience across different mobile devices, so you can drive the experience from your desktop on an array of mobile devices, so you can do a synchronized testing experience. Edge Web Fonts, Typekit, both about typography and very visual and types of experiences on the web, and also PhoneGap Build. So that leads me into Adobe with HTML and mobile applications. So PhoneGap is a tool that allows you to build natively installed mobile apps, so they can be deployed through like the App Store and things like that, using HTML and related technologies. So the techniques that I'm going to talk about can be used with these tools, can also be used with PhoneGap to create both experiences targeting the web, so mobile web, desktop web, but can also be used to target natively installed mobile applications. Adobe also contributes to the development of the HTML5 spec and web standards. So we actually have a web platform team that all they focus on is helping evolve the web forward, push the web forward, and evolve the capabilities of the browser based upon the experience that we've learned with the Flash player. And this is everything from CSS regions and CSS custom filters, which are like highly cinematic visual type of effects, CSS exclusions, so nonlinear shapes. So, and that's really interesting also, like CSS exclusions and regions can be used to have basically text from one piece of the screen flow into another piece of the screen inside of a non-standard shape, and you can use that to create interesting visualizations also. But I'm not going to go into too much detail on that. But here's an example that I wanted to show, and this is the last part of the Adobe products I'll talk about before getting the underlying technology. But this is kind of a simple data visualization sample that's available. Oh, and one other thing, all the HTML tools that I talked about are freely available. Well, most of them are freely available on html.adobe.com, but you can go and check those out if you want to. But here's an example that was created using Edge Animate, which is a timeline-based animation tool for HTML experiences. And I'll go ahead and click on North America. It's going to zoom in, and it's going to do a small chart that you see here on the left-hand side. And this is mobile browser market share. I don't remember what the date they actually captured this data was for. But this is an interactive experience that you can see. It's animated, it's visual. I can go and click on different regions. The data zooms in and out. But this is entirely built with, it's visualized in HTML, CSS, JavaScript, and it's built using the Edge Animate tool. So I just wanted to show you that to kind of give you an idea of what you can do with the Adobe tools. And now I'm going to start talking about the underlying technology. So I mentioned that, how do we actually go about visualizing data? And let's start with the most primitive aspect of getting information on the screen in a non-text format, and that's an image, standard image tag. Anyone who's done HTML before has probably used the image tag, and basically what you're doing is you're requesting data from a server. You hit a URL, it returns you an image, you can do it dynamically generated from the server. But there's not a lot of wow factor to this. It's not interactive, it requires a server round trip, so there's no wow. An example of it is the Google Image Charts, which is actually deprecated. They're not going to continue supporting it going forward. But this is the most fundamental aspect of how do you start displaying information. Nobody gets excited about this. It's been around since the 90s when the internet came to be. And it also doesn't work in things like offline scenarios, where if you have a natively installed app that's built on web technology, you can't use it on there if you're offline. So let's talk about the HTML5 Canvas. Now, how many people have actually tried to use the HTML5 Canvas so far? Okay, a good number of people. So you guys already know at least a bit about what I'm going to talk about here. So the HTML5 Canvas is exactly as the name implies. It's a canvas, so in this case, we have the canvas tag. And what it is a blank canvas on the screen. If you were to just put a canvas and not put any script behind it, you'd have just a blank rectangle. And what it gives you is a programmatic drawing API so that you can do basically down to pixel level manipulation of the content within that canvas. So if I wanted to say, I want to draw a line from point A to point B, or if I want to draw a curve, or if I want to draw a circle, I can do that. And basically what happens is you play a complex game of connect the dots, and then next thing you know, you're rendering very complex, very intricate shapes. And that's essentially a foundational building block into creating interactive data visualizations. What's really interesting about this is it's totally client-side rendering. And when I say client-side rendering, I mean everything that is visual in this is actually rendered in memory inside of the web browser. So once you have your application experience loaded in the browser, you don't have to have, let's say, a request to a server in order to cause this to redraw. If you have the information in memory, you can have it redraw. And that gets really interesting if you're in kind of like offline state. But it also makes it so that it can respond to input. So if you're clicking on an element, or you want it to animate based on data that's coming in real time, or if you want it to, I don't know, it can get as complex and crazy as you want. I'm talking about the data visualization kind of scenario, but if you've ever seen a lot of really highly visual interactive HTML games, a lot of them use HTML5 Canvas, and you have characters running around the screen, explosions, whatever. It can be a very, very powerful medium for interactive graphics. So as I mentioned, it's a programmatic drawing API. You can use it to draw circles, draw arcs, or basically the same thing, draw lines, draw quadratic or cubic Bezier curves. You can also get down to setting at the individual pixel level. So let's say if I have 200 by 200, I want to say, oh, I want the pixel at 50 by 50 to be red. And if you're getting down to that really low level, pixel level manipulation, you can get very, very, very fast processing speed and render a lot of data that you might think unimaginable in the browser. So I mentioned it's very dynamic, can work in offline scenarios. And an example library that uses this is rgraph. Has anybody used rgraph? Okay, a couple people. It's essentially a chart visualization library built on top of the HTML5 Canvas, which allows you to do dynamic client-side rendering. So you don't have to build the chart yourself. You can leverage a library that already does a lot of this for you without having to come up with the custom graphing logic on your own. But if you did want to do it from your own, the basic way to do this is the top left corner is your registration point. This is 0, 0, just like most other languages in computer graphics. If you want your data to be displayed across this square, based upon your data values, whatever range you want to put it, if it's a bar chart, column chart, generally you want to swap the axis so that your registration point is down here. It's a little bit of math you have to do to switch things around. But then you can start drawing, and if you want a column to be 100 pixels tall, you draw it from here to here. The next column, you draw it here to here, here to here. Next thing, you have a bar chart. It's actually, once you start putting the pieces together, it's really easy to create some interesting visual experiences. Now, I mentioned a bar chart, well, a column chart in this case, and here's the code that does it. I've kind of cut out all the specific stuff where you have to get a reference to the canvas first, but this is JavaScript, and what I'm basically doing is I'm looping over an array. For each data point, I'm calculating the x position, which is the increment, which is the number of columns. I'm calculating the height, which is the height based upon the data that's passed in. And I'm calculating the offset from the top, because we want it to be aligned along the bottom. And then once I have the x position, the y position, and the height, I'm going ahead and just filling a rectangle, and then doing a stroke rectangle based upon the x position, the y position. Then, okay, the width, which in this case, there's a little calculation happening here to programmatically determine how wide I should make it. And then the actual height of the bar. So just by looping over this, doing a really fairly simple operation, it's gone ahead and programmatically created this column chart that you see right here. And this is, so I haven't stuck an image in there, that is an HTML5 canvas. And it's really easy once you start putting the pieces together in your mind. How do I script this? How do the different pieces go together? How I can start making some really complex data visualizations. Now, what's also interesting here is I haven't built it into this example, but what if I wanted to if I mouse over a certain area, or if I'm on a tablet and I want to touch a certain area, I can calculate based on the XY coordinates. What am I hovering over? And then I can cause it to redraw just the area that I'm hovering over, and you can start adding some really rich type of visual effects. Some really cool things can happen there. Here's another example where I tried to make a really basic scatter plot. And what I did was take literally the exact same example, but rather than, and all the data is randomly generated, just in the browser here. So what I did was take the exact same example, and rather than drawing columns, I gave each data point both an x and a y property. X and y. And then all I did was calculate, based on the range here, where should a circle be drawn for each given data point. And all I'm doing is setting begin path, which is part of the HTML5 Canvas API. And that leads me into another kind of topic. With the Canvas, you can set what are called paths, which is a series of instructions that once you fill them or once you stroke them, it will go ahead and it will render everything that you've put into that path. So I'm beginning a path, then I'm drawing a bunch of arcs, so a bunch of circles. I'm setting the XY position, setting the radius, and then also saying it draw a full 360 degrees. And then once I've looped over all of them, or excuse me, for each iteration of the loop, draw the arc, I fill it, I set a stroke on it, and that ends up with what you see here. So there's kind of a light semi-transparent red, looks kind of pink with a black stroke around it. And now there's other code in this example where I've looped over and put some grid lines in based upon the range here. I think the ranges in them were from 0 to 10 or 1 to 10. But you can get the idea that using a very simple set of instructions, you can programmatically create visual elements that can be used to create a much more complex picture. Now, these are really, really basic examples of a really simple column chart, a really simple scatter plot. But now let me show you something else. So this is an example I put together just to kind of see how far can we push a HTML5 canvas. And what it is a scatter plot that has 10,000 data points. This is totally rendered inside the HTML5 canvas. And it's not only a scatter plot with 10,000 data points, but we've also got a histogram so we can see the density of the distribution of each individual point. Now, this is totally rendered client side. And what's kind of cool about this is I can also go ahead and let me just zoom in. You can see I can redraw. I'm zooming on different pieces of data. And when I say we can make things interactive, like this is what I'm saying, where you can make it very, very interactive. So basically, just by clicking on it, I'm gathering X, Y positions, and by knowing the range of data that is in my current viewport, I can say, oh, I can determine if I have a rectangle from here to here, and I know that this one is from 39.3 to 45.38, calculate the percentage of this X position corresponds to 41 and some change, or whatever, and you can then zoom in on that particular area. You reset the viewport of where you're trying to draw and just redraw it. And the way that I'm able to render that many pixels that fast, if you're trying to do like move to line 2 or draw rect or draw arc, you're not going to be able to do 10,000 data points because the instructions that it takes to render all that would be very computationally expensive. When you want to get really high performance, this is a case where I'm setting individual pixel values. And I can jump into the code for this. But before I do that, I want to actually show another instance of this. So how many people think 10,000 data points is a lot to render in the browser? Okay, not that many people. Oh, come on. I thought I had a better example than that. How about 1 million? And I can also take that and zoom in. And so all the data for this I've actually randomly generated with a bias to 0, 0, so it's more dense down here as opposed to 100 by 100. But basically, if you have real meaningful data and not my randomly generated mess, you can start to get a very, very powerful visualization type of scenario. It's highly interactive. You can drill down into it. Oh, wait a minute, look, it works in a web browser, so if I put it on a server, all of the billions of machines that are connected to the internet, as long as they support HTML5 Canvas, can now interact with this. That means it runs on my iPad, it runs on my desktop computer, it runs on my Android tablet, it runs on my phone. Now, 1 million data points might tax a phone, don't doubt that. But this actually runs really well on, I have an iPad too, it runs great, even the 1 million data points example. The longest part of it is actually generating the data, and if it was using real data, the longest it would take for 1 million data points is actually serializing that data to the client, so getting that data onto the client so it can be rendered, not the actual rendering process. So, does anybody want to jump in and see the code, how that works? Okay. And I'm going to be making this, well, most of this presentation is actually already on my blog, but I'm going to be making this presentation available on my blog also, so that if you want to see all of it, it's free to download. You can check it all out. So let me jump over to... So I mentioned Adobe has some tools. This is Adobe Edge Code, which is a HTML code editor. Actually, let me jump back down here. And pause. Jump. So this is the 10,000 data. Or no, sorry, that one wasn't 10,000. That was 50,000. Is that more impressive than 10,000? Okay. So you can see when it initializes, I'm just looping over 50,000 iterations, generating a random value for each point between X and Y. And there's not a lot in my actual HTML, or my... Can you guys read that, first of all? So, I'm generating the data randomly. If I scroll down, if I don't do it too fast here, you can see that in here, where is my chart? Oh, I must be creating it programmatically. I haven't looked at this code in a while. But let me actually jump to my chart here. Okay, so here I have it. I'm generating some HTML. Inside that HTML, I have different labels. I also have a chart here somewhere. Sorry, my canvas. So here, and then in this example, I'm using jQuery. So jQuery is a library that allows you to easily manipulate the HTML DOM without a lot of extra scripting. It abstracts some of the complexities between browsers away from you, so you don't have to worry about it. So what happens here is I'm actually creating a canvas instance just by generating an HTML string, creating the canvas, appending it to the HTML DOM, and then I'm calling my render function. And in my render function, it'll go through a couple steps. So here's my render function. The first thing that it does is we get the width and height. We calculate the actual chart width and height because if you notice there's a border on either side that's used for labels and also for the histogram. Sets a fill on it that's completely white. And then I'm getting, I don't remember why I've done that. But it goes through a couple different steps and it'll put in the grid lines that were used in the, as the background of the chart. Let me jump back over here so you can see. So, and then once I have that map of what's the actual distribution for the histogram, there's a lot here. Like I said, I'm going to make this code freely available. What it does is it calls a function that I've created here called setPixel. And what that does is it gets the image. When I said I couldn't remember why I was grabbing the image data, I'm using it here. So the actual image data is an array of basically numeric values which represent the values for each individual pixel in that entire canvas. So if it's 800 by 600, it's an array that contains, I don't know, do the math, that many number of numeric elements that represent the values for each pixel. And so what I'm doing is actually setting at whatever position +0 is a red value, +1 is a green value, +2 is a blue value, +3 is the alpha channel. And so using this, you can very, very, very rapidly iterate over every pixel or in the image, or you can, let's say if I, like I said, 1,000,000 data points, you can iterate over that 1,000,000 data points and just set a pixel value rather than for 1,000,000 data points say, oh, go here and draw a circle. Because if you think about the amount of computational logic it takes to draw a circle and then do it 1,000,000 times, that adds up very, very, very quickly. So that's the 1,000,000 data point example. I didn't create this visualization, but this is the type of thing that you can do with the HTML5 Canvas. I just came across this on Twitter yesterday, and let's forget about the political discussion that could go with this because it's gun murders in 2010. But I thought the visualization itself was actually really, really cool. So what you can do is, let's say if we want to filter this by the type of gun, or if we want to say, oh, it's rifle, or we want to say age group, if we want to do children, you can drill into this information. It can be highly animated, highly visual. And this is all done using basically the line to methods, so that in the HTML5 Canvas, you're drawing a line from here, or you're drawing a curve, or whatever you're doing. And basically, this is showing the number of people that were killed by guns and the number of years that were stolen from their lives. Like I said, I want to avoid the political thing, but I thought it was a really good visualization and a really great use of the HTML5 Canvas.
What's the yellow and the white?
The yellow is
okay.
the number of people killed. The white is the number of years stolen. And you can scroll down and get some more. Whoops. Why is my button not working?
It looks good. It's just not clear what
Yeah, it's.
The yellow is the beginning, and that's when the yellow stops, they die.
Yeah, when the yellow stops, they died, and the white is what the projected life expectancy would have been. But I don't know what logic they were actually using to calculate those numbers. I was just looking at the actual visual experience itself. And don't kill me for any politicizing of it, because all I really wanted to do was show a really cool Canvas experience. So let's talk about SVG now. How many people are familiar with SVG? Okay, so I don't need to explain every detail about it. I'm done. Okay, SVG, Scalable Vector Graphics. In the age of retina displays, this can be your friend. Because if you're doing things that are based on just images, actually, take a step back. Like the canvas can be also your friend with the age of Retina displays, because you can have it draw up whatever your device resolution is. But if you compare an SVG to, let's say, a static image, SVG, because it's a vector graphic, it's going to be very crisp, very clear, regardless of what pixel density you're using to view it. Whereas, if you have an image that's at 72 dpi and you view it blown up in a web view that's at 240 dpi or whatever the iPhone is, or the iPad 3, then things get pixelated. But basically, SVG is a declarative vector graphics markup language, so you can use it to create complex vector shapes using text-based input. What's really interesting about this is you can also programmatically create these vector elements in JavaScript. And that's where things start getting really interesting with HTML-based visualization. So, let me refresh this, because for some reason my browser's doing weird things ever since showing that last visualization. So what we have here, this is actually a chart that was rendered using a charting library called Highcharts. I've used this in multiple applications. And what it does is, based on the data that you pass into it in JavaScript, it creates an SVG graphical representation of that. And if I go ahead and inspect element here, you can actually see the SVG itself. So we've got the SVG shape, and this complex shape is made up of some rectangles, some complex paths, which I'm not going to get into the specifics of SVG specification, but you can set a fill on each one of those, whether it's a solid or you can set colors to it. And then you can set a complex path, which is basically a series of XY coordinates where it's going to draw a vector shape between all those different XY coordinates. We don't need to worry about all of that right now, because I really just want to talk about how you use SVG. They can be created programmatically on the client or the server side, so you can render SVG. SVG files can be static text files. They can be dynamically created on the server side, or you can create them totally in JavaScript, totally on the client side. Where SVG is different than the canvas is that the canvas gives you individual pixels, but the SVG is really more of a coordinate plane, and you're drawing vectors between those different coordinates. And like I said, they can be static or dynamic. Where it starts getting interesting is each individual SVG element is actually part of your HTML DOM. So just like any HTML element that's part of your DOM, you can add things like mouse event handlers to it, like a click event handler or a touch event handler, and then so it can be highly scripted. So if you interact with it, it has behaviors associated with each individual element. Now, if you're doing HTML5 Canvas, it's one element. It's the canvas. You draw on it programmatically, and then you have to do any kind of logic yourself. But with SVG, because they're part of the DOM, they have all the functions that an HTML DOM element has. You can do some really interesting things. Before I jump into the examples, here's a couple frameworks that you can use to create HTML-based visualizations. Highcharts is the one that I showed here. Sencha Touch charts. Sencha Touch is a suite of JavaScript-based components for building applications. They have a charting component to it. Kendo UI is another user interface components in JavaScript. They have a charting component too. Google Charts, so not the Google image charts, which I mentioned earlier, which are just images, but the actual Google Charts are basically they render SVG. There's, oh, I forgot a comment here, but D3 is a really, really interesting data visualization framework. D3 stands for Data-Driven Documents, and people have really been pushing this a long way to create like very highly interactive, very visual, very rich types of experiences. And I think, did you guys already have a presentation on D3? Or,
Christian? 2 months ago.
Okay.
It was map focused.
Okay, so it's map focused. But you can do a lot of really cool things with D3, and there's a lot of examples in their samples that focus on SVG-based visualization. I'm going to show a couple of them in a minute. Another really good library is, there's Raphael.js, which is a library focused just on SVG, and there's Raphael, or what, I can't pronounce it, I'm butchering that. But it's g.raphael. I don't remember what the extension is for the website, but basically it's built on top of the Raphael.js framework, and it's totally based around charts on the Raphael.js library. Now, I really like this visualization. I didn't create this one, but if anyone else likes James Bond movies, you might like it also, or you might just think it's a cool looking visualization. But basically, each element that's in here, I can mouse over individual elements and have events. I can I say I, but I'm using that figuratively. I didn't do this. But it's a great visualization. So each one of these elements is actually a piece of SVG. You know, whether they're parts of vector shapes, even everything down to, I believe, each little icon. So in the markup language, it describes all the XY positions for drawing paths to create all these complex shapes. Where it's interesting where I said each element is scriptable. So each icon or each piece of the chart, you can attach behaviors to it, like a hover behavior or a click behavior. And so that's what's happening when I move the mouse here and it's animating the different pieces, and it's basically just a hover event over the DOM element, triggering some JavaScript, which causes the content in the bottom here to be animated out, or the old content animated out, new content animated in. What's also interesting is that because they're elements in your DOM, you can use something like jQuery, and let's say if you want to programmatically change values in there. So if you wanted to animate the actual chart itself, basically you're just animating properties of the DOM. And so you can create some really interesting, really visual type of examples here, and the code behind this is comparatively not very complex. So that's an example of what I think is an interesting SVG-based visualization. Now I mentioned D3. This is an example straight from the D3.js examples page. You can do some really cool things. Like, so if I'm selecting this one area, it highlights all the different data points in different views for the information that's contained within that chart. Jump to another one. Sankey Diagrams, which I haven't worked with these that much myself, but it's my understanding that they map the flow of energy from one source to another. I just think they look cool, and it's a great example of an SVG-based data visualization. But because I can have actions on individual elements, so individual quote-unquote DOM elements, then I can attach behaviors to them, whether it's changing color when something's highlighted, or whether it's on a click event, I'm having it respond to different events, like I can drag it and I can move things around. And this is one of the examples on the d3.js website, so you can download it, check it out, and get started with it, and start building your own applications on top of this. I thought that was a really good one. Here's another example, bullet charts, which are basically a variation of just a bar chart, but you can see that there's different pieces on here, lots of different lines that represent the different values, but when I hit update, they're animating. Basically, these are just parts of the HTML DOM that are being animated. Well, the SVG components within the HTML DOM that are being animated, and give you that interesting visual type of scenario. So, we talked about Canvas, we talked about SVG. I didn't go into too much code with SVG, but I definitely highly recommend checking out the SVG Visualization Libraries, because they abstract some of the tedium and the complexities of SVG away from you to make it easier, and you can focus on building the interactive experience as opposed to building, declarative SVG markup. So the next thing I want to talk about is HTML DOM. And, when I talk about HTML DOM, I'm talking about the creative use of standard HTML elements to create something that's a little bit more visual. Now, when I talk about this, there's one usage scenario that I like to share first, because when you kind of step back and you break down all the different components, you can understand what I'm talking about. Where I'm saying it's just HTML DOM, the regular HTML elements. And if you already did a data visualization or a meetup on maps, where are my map tiles? Come on, network. There we are. Has anyone written an interactive tile engine before? It's really fun to do, I will say that. But basically, the way that all mapping works, interactive mapping works that are built on top of a standard HTML and JavaScript interface is there's basically a div, an HTML div. Inside of that, there's a layer where there's a lot of image tags. Each one of those image tags has a basically set of geographic lat-long coordinates that are associated with it. Now, you can, just by taking the lat-long coordinate, if you have all the algorithms that are associated with it, you can determine how a pixel on an XY plane corresponds to the lat-long value. And from that, you can determine which actual just plain old pictures, just images, do I need to line up to create a greater composite that is actually something that is much more meaningful than just a couple of pixels on the screen. So if I go ahead and zoom out here, you can see that the tiles are loading in, and you can see what I'm talking about. So that when each individual square lines up, they're actually it's just an image, that's all it is. And there's creative use of JavaScript in order to, one, add interactivity to it, so that when I click on a drag and I pan, we load in more images from one side to the other, or depending upon the direction that you're actually dragging. Or, excuse me, is there any water back there? All right, I've run out. But basically, we have all the different images that make up the composite, but then we're also just using JavaScript to add interactivity because they're just standard HTML elements. Now, if we wanted like point and polygon overlays, or if we want images overlaid, they're really just standard HTML elements. Now, granted, if we're doing directions from here to here and we want to follow every street, well, maybe we use SVG or something like that, which, for all intents and purposes, yeah, it's vector graphics, but it's part of the HTML DOM. But if we just want to put a marker that represents, every Starbucks, which the map would be probably totally covered. If it's a Starbucks, so it's just an image. So I think maps are a great example of using just pure, plain old HTML elements for an interactive data visualization scenario. And now what's also great about this is, I've been talking about HTML5 and how it adds interactivity and graphic support. These are HTML, I don't know, probably 3 compliant. It's just standard HTML DOM elements. Thank you very much. So, with that, let me go ahead to the next one. Now, this is actually a screenshot. I don't have the live one up and running right now. Of an app that I was on a team, we created it, and it's for visualizing CRM information. And this is all just totally fake data, so it's okay. But it's actually being used inside Adobe. And we created it so it can be used in the desktop browser, but it's also a PhoneGap app, so it can be used and natively installed on both Android and iOS platforms. Now, all of the elements that you see here, everything from the interactive slider to the bars, and there's multiple little colored sections in each bar, everything is just plain old HTML. The way that this works is, and I just realized I'm talking into the wall. Can you guys hear me? Okay. Let me try standing over here and talking this way. But basically, this is just an HTML table. Actually, not even just a table. They're div elements with the CSS style of table row and table cell. So this is a table row, and in that table row we have multiple cells. We have one here, and then we have one here. And then inside this there's a div that has, based upon we know the data range. It goes from 0 to I think it's 1.3 million, and that's dynamic based upon all the data that comes in. But we can calculate for this data point, and this, by the way, is all rendered client side. But basically, for this range, and we know that this data point is only $100,000, so we can say, what percentage is 100,000 of the total range, which is 1.3 million? So we calculate the percent, and then all you have to do is use CSS styles to do a percent-based width on this div right here. And so the corner rounding is just CSS3 corner rounding. You might be able to see on some of these there's actually a stripe, and there's obviously the bevel on the edge. That's all just in a CSS background image that's repeated horizontally on this HTML div. And so inside of that, actually not even inside of it, but inside this same container, there's another div which represents the smaller colored bars. And so for that, it's using the same technique. It's just using a percent-based width based upon the total range, and it's got CSS styles applied to it to set the different colors, the colors and the patterns. And so I wish I still had it up and running, but it's actually hooked into Salesforce, and anyone who's ever worked with Salesforce knows that when something goes live and you're a developer, you can get locked out of it. So that's why I don't have it up and running. But basically, all of it's dynamic. If you move the slider, it changes the values that are used to calculate the small bar. So as I'm sliding in real time based on JavaScript, it's just updating the width of these, and so They move back and forth in size, and it's a very rich, very visual, and very polished looking data visualization type scenario, but it's just plain old HTML div elements and CSS styling. So that's all that it is. And again, I talked about HTML5. There's nothing about this that's HTML5 except for the CSS rounded corners. That's it. So I wanted to take that same example and break it down to a really, really simple one. What I've got is a bar chart and a column chart. And all these are just HTML div elements. And let me actually go ahead and jump to the code for this one. So, where did I put it? Dot chart. So basically, for each bar in the bar chart, I have a div element. Well, I have a couple wrappers on there just to get things so that they line up correctly and they display correctly. But for each one, it's just using the positioning of the browser, so it's div, div, below div, below div. And then I'm just setting a style, a width, so this one's 80%, this one's 70%, this one's 50%, this one's 60%. They're just percent-based widths on divs. And you can either use the default browser spacing to stack them vertically or horizontally or whatever, or you can use CSS positioning, so fixed position, so it is in a certain XY position, or if it's whether it's top, bottom, left, right position, you can say, oh, it's always going to be X pixels from the left side, and it's always going to be Y pixels from the bottom, and then the percent, the height is percent based upon whatever data, how you want to render it, how you want to process it. But the root of it that I'm trying to get to is that there's nothing special about this other than it's a creative application of just standard HTML div elements. Any questions at this point? You guys have been quiet. Yeah?
What's the advantage of using standard HTML elements as, say, SVG? I can think of one way to disadvantage.
The advantage is that well, I'd say two advantages, and I would say any one of these, there's pros and cons to all these. But the advantages, I would say, is that it runs pretty much everywhere. If we take Android, for example, if you go back to Android 2.3, I think is where these issues. After 2.3, it starts getting better. But 2.3 is the most predominantly installed version of Android on all devices on the planet. Android 2.3 doesn't render SVG. I think it has performance problems with Canvas, but it can render standard HTML just fine. So it would be, the one advantage is an approach like this is supported in more places.
The counterpart to running everywhere is running slightly different everywhere, right? So you're going to have to work around quirks in the implementation, affect different platforms.
Well, and that's one of the things with web development in general. Unless you're locked into a particular browser, you say, oh, we're only going to support Chrome, we're only going to support IE, you could run into that pretty much anywhere.
For SVG and Canvas as well?
Well, for SVG, yes, because it's not supported on older Android platforms, but it's supported on newer ones.
But when it is supported, it's supported consistently?
Yeah, I would think so. I say that there's probably some caveats there that you will never find out until you're deep in development and it's midnight and it's due tomorrow. What's wrong? Okay. No one's experienced that? Come on! But yeah, I would say as far as benefits to each one, it really depends upon the use case, what platforms you're targeting, how you want people to interact with it. Do you want each element to have events applied to it, or do you just want the canvas and you just want the visual representation? How much control do you want over it? Because while this is really easy and you can render it pretty much anywhere, you don't have a lot, or it's not as easy to create something that's as customized as you can create with SVG or with a canvas.
But it works everywhere.
Yeah, but it works everywhere.
Work everywhere. But the rounded corners work the same everywhere? Well, no.
the rounded corners, yeah, that's one part of it. But if you just want the meaning expressed through the visual component, and all you truly care about is it the right width for whatever range I'm trying to project, then yeah, that does work absolutely everywhere. Somebody had a question over here, I thought, but okay.
Mine is pretty general. I just wanted to know what you thought the difference was between charting and data visualization. For you, software changing it, and just think there's a...
So, I mean, I think charting is a component of data visualization. Where data visualization, and I come from a developer background, not from like an information data visualization type background. I just am fascinated with trying to get visual information on the screen. But charting is just, it's a chart. It's a way to get data up there that, they're common visual paradigms that people can easily look at and understand. But the data visualization part of it is, how does it all work together, and how does this meaning, how is this visual piece actually conveying meaning to who's ever using it or who's ever consuming it? I might be totally way off on like the textbook definition of it, but that's what I interpret.
Sounds good to me. And actually, we have a new member. I'm not sure if they're here tonight. They said that their definition of data visualization, we've had a million of these, almost all of you have answered this question, but I liked it in 2 words. They said it was cognitive ergonomics.
That's a good one. You had a question also?
So, before when you talked about Edge Animate, the HTML versus ActionScript based language apps for Adobe, how does that compare to Create.js?
So, conceptually, they're trying to do the same thing. Create.js toolkit is based upon HTML Canvas, and so how it ties into Flash Professional. So if anyone doesn't know what I'm talking about here, Create.js is a library in this Create.js toolkit that you can use to create interactive experiences using Flash Professional and export them out to HTML as the runtime. But yeah, Create.js is based on Canvas, where Edge Animate, you're actually animating DOM elements. That's the biggest difference between the two of them. Other than that, they're both timeline-based animation tools, and they have a lot of really similar paradigms. There are definitely differences between the two of them, but that's, I'd say, the most fundamental difference is just one's Canvas, one's DOM.
Okay, because actually the timeline functionality is what makes Flash stand out. Because if you have to hard code animations, it's really technical.
Edge Animate is, I don't want to take too much time. I'm like, I could fire it up and do all this, but I don't want to take everyone else's time. But basically, it is a timeline animation tool. It's intended for designers, not developers. So the drag and drop, you move your position on the timeline and you can animate things, move them around. It's free to download and try it out if you haven't already. But yeah, that's just the biggest difference is Canvas versus DOM. All right, so I don't even remember what my next one. Oh yeah, WebGL. WebGL is really exciting because it's hardware accelerated.
Yeah, sorry, I had a last question. I'm really interested in BI solutions, especially ones that are connected to, for instance, SAP systems or Oracle databases, or in general ERP solution, enterprise solutions. You mentioned Salesforce previously.
Yes.
Do you guys at Adobe, do you have any prepackaged solutions, or is it run, for instance, mobility applications?
So we don't necessarily have prepackaged like components or visualization pieces for Salesforce, but Salesforce, their hybrid SDK, which hybrid meaning HTML mobile SDK for natively installed mobile, is actually built on top of PhoneGap, which is it's Adobe open source PhoneGap is Apache Cordova, but it's the tools that you can use to build natively installed apps on like iPad or whatever tablet or phone using HTML-based technology. So any of the libraries that I'm talking about here can actually be used to render Salesforce data inside their mobile hybrid SDK, if that makes sense. The Salesforce is like a unique one. They have a native SDK, and they have a web SDK, and then they have a hybrid SDK.
Salesforce.com and everything like that. But with regards to ERP solutions, for instance, SAP, SAP is pushing out their mobility solutions.
Yes.
That's going to be a big thing. So do you have any solutions that can, in an easy way, fast? It has to be fast, cheap, and look pretty and be nice.
I'd say we don't necessarily have like pre-built components. There's a lot of third-party vendors that do those kinds of pieces. But Adobe does have a partnership with SAP to also leverage PhoneGap for hybrid mobile applications. So basically the same way that Salesforce does it, Adobe has a relationship with SAP for the exact same kind of situation. And let me get my iPad real quick, and I can show you kind of what I'm talking about. I'll just do one of these show and tell kind of situations, but let me pull one up here. If I can get my password right. There it goes. So this is not an SAP app. I can't show it because I don't have this going through the network. But basically, this is an app. It normally has charts here, but I'm not connected to the network, so I can't do it. But all the charts are actually rendered using the same charting library, so it uses Highcharts charting library that I'm talking about. That's for a developer to implement, so there's not something that's like really quick drag and drop, something like that. Although Salesforce does have the Salesforce Touch SDK, or it's not really SDK, the Salesforce Touch framework, which is an HTML hybrid framework, which employs a lot of these same techniques we've talked about, but that's actually from Salesforce. Hopefully that answered your question at least a little bit. I know it's not the exact answer. So WebGL, I'm going to go ahead and launch an example that I think it was produced by Google. I know it's a Chrome experiment to show off the capabilities of the Chrome browser. But WebGL is a basically 3D rendering, hardware accelerated API inside the browser to render complex and very, very high performant, very rich 3D visual experiences. Well, it can also be used for 2D visual experiences too. But it's hardware accelerated, it's highly performant, all the logic, all the scripting, everything is JavaScript in there. It's not yet a standard. It hasn't been approved by all the different standards bodies. It's not supported in every browser, but where it is supported, you can do some really, really cool and very stunning type of visualizations and interactions. So for example, this is a globe with orb population from 1990 visualized on there. I can spin it with inertia. It's got a very good frame rate. It's very, very visual. Let me go ahead and switch to 2000. We can actually see the data animate if you look closely. You can see the data points animate as I hover over them. And everything that's a part of this is purely, I can even zoom in there. So you can do a lot of really interesting things, but WebGL, basically think of it as OpenGL for the web. It's a graphics language specifically for those high performance 3D geometries and very rich visual experiences. And with that, that's pretty much it for my presentation, Data Visualization with Web Standards. Like I said, my name's Andy Trice. I'm a developer evangelist with Adobe, and if you have any questions about this, I'd love to be able to answer them for you. Or if you want to learn more about any of the products, I'd love to be able to answer questions about that for you also. My email is atrice@adobe.com. My blog is tricedesigns.com. On Twitter, I'm Andy Trice. And I have a ton of open source stuff, including the million data points thing. Actually, million data points is on the blog. It's not on my GitHub account, but I have a bunch of other interactive experiences and mobile apps, which are sample apps that anyone can download on my GitHub account. So, thank you.
Thank you very much.